Hello everyone and welcome to the next lesson. In this lesson, we are going to be talking about D2. D2 is the deacceleration and acceleration. Now, what are some of the considerations? We are going to understand why are acceleration lanes important. And you shall find that if I'm just to highlight here, you shall find that deacceleration lanes are very advantageous on high-speed roads. So we are going to understand the advantage of deacceleration lanes. Deacceleration lanes have a number of advantages because you find like on high-speed roads, they leave the driver no choice but slow down. So you may be asking yourself, why do we need deacceleration lanes? Remember, if someone's approaching a junction, they've perceived there's a junction, they need to deaccelerate all the way to the stop line. And what are some of the considerations we make? So you find deacceleration lanes, one, help reduce someone who has been moving at a very high speed, lowering all the way down and coming to the junction. Now also the reverse is the same. So there are junctions where there's no stop control, and you find that once you've used the junction, you need to accelerate back. So for example, you can see here, when someone makes this turn, they need some form of acceleration back into this lane for that case. Now there are also other cases whereby here it's a deacceleration. Traffic has to come in this case and deaccelerate as they try to reach the stop line to yield to pedestrians crossing. So that's one importance. But what do we consider? And you shall find that in your notes, they talk about the deacceleration rates that we can use, especially for left turns. This can come to something about 2 meters squared per second, which is roughly around 6.5 feet per square. Now, you shall find that what we use in rural and urban are very different. And if you're really interested, I went into these details because you are going to reach sections whereby you may not have sufficient space for that deacceleration, and you are maybe going to assume a lower acceleration rate. You have to know the values that were used. As I mentioned, you may find that some cases the 2 meter per second squared is not practical in some situations. And you shall find that you may now have to look at the stopping side distance. For example, for 50 kilometers can be around 50 to 60 meters, which can be roughly around 200 feet as the stopping side distance. And that's something you're going to look at. And you find that in that case, it looks at something like 3.4 meters squared, okay? Meters per second squared. Same thing with 11.2 feet. And that's a factor that we can look at. Now, as a result, when you have this consideration, again, it's up to you to use engineering judgment based on site conditions. If you're ever in a situation whereby you're designing the junctions, it's good to start from somewhere. And this is why they recommend what we call the desirable lane, okay, changes, which are deacceleration. So one table is in the US, is in feet, the other is in metric. So if you're designing for, let's say, 30 miles per hour, which is around 50 kilometers per hour, you can use 50 meters for that. And most of the cases, I normally use 60. I always start with 60. I always don't try and use the minimum desirable. I always add something. But in case you're stuck, you can use that. If you're designing for something like 25 miles per hour, which can sometimes equate to 30 kilometers per hour, you can use your lane as 25 meters or 105 feet. Now, the purpose of these are starting. And again, I've indicated here the assumptions based on that. Remember, you have to defend these designs that you are preparing in your report, which we talk about in the professional design course. So in the professional design course, we show you how when you're writing the report, you are able to know what to include. Your report should look professional. It should show you have thought through your junction and you have designed it well. So I hope to see you in the next lesson where we talk about D3.